Rise over run, okay? So right now, this line right here, what is the slope? By the way, what I'm doing right now is not, you know how sometimes I give you like random stuff that's like not on topic? Like this is not something you're tested on, but I'm about to throw a formula on the board and I'm trying to show you where it comes from, all right? So it is relevant. Okay, so it's rise over run, right? Let's start with the run, because the run's easier. Go ahead. What is the run? Isn't that this distance right here? What is that distance?
It's just the plus h.
It's just the h. It's just the h, isn't it? Think of it this way. If this is 3 and this is 3 plus 1, then the difference is only 1. Now, how do we technically do it? What's the formula for slope? Isn't it y2 minus y1 over x2 minus x1? That's the formula. So what I might do better with here is to actually label these points. Pay attention. This is going to be really, you're either going to see this or you're not. This point right here, what is its x and y coordinate? So what is the x coordinate of this point? X, okay. What is the y coordinate of this point? We don't know, do we? We don't. But if we call this function, the blue function, if we call it f, then isn't this height the function's value at x? F of x. Okay. Now, what is this point? What is its x coordinate? X plus h. Ooh, and what is its y coordinate? F of x plus h. That look familiar? Wasn't I just asking you to plug x plus h into something a little while ago? It wasn't just for fun, it's because it comes from that y coordinate of that point. All right, let's call this x1, y1, x2, y2, and let's plug into the formula. What would I have? What would this formula become? What's y2? F of x plus h minus y1, f of x, over x2, x plus h, minus x1, which is x. Yes? Okay. On the bottom, what happens to the x's? They cancel out. So I get our master formula right here. This is it. This is the master formula. This is the one we're about to mess with. It will be the slope. I'm going to put m instead of slope because that's what we used for slope. F of x plus h minus f of x all divided by h. Big box, big stars and fireworks. Okay? This is called the difference quotient. And the difference quotient is something that every student that gets through this class better be able to do in the next class, or else you're not going to be able to do the calculus that you need to do. So if somebody hands you a function, all right? If I just hand you some arbitrary function, here it is, boom, here, and I ask you to find its difference quotient, this is what you have to compute, right here. And we're about to do it, all right? We're going to do a couple of examples. I said this is going to get bumpy. This is it. This is the bumpy part. But do you understand that that answer represents the slope of this red line? Then in calculus, what we do is we compute this, and at the very end of computing it, we let h go to 0. And what that does is it slides that point over on top of itself, and it becomes 1 point, and we actually get an answer. And that's called the limit. But again, that's calculus, and you'll do that in the 1325 class. That allows you to get the instantaneous speed of something. All right, here we go. Difference quotient time. Example. Find, I'm going to call it dq not Dairy Queen. Okay, difference quotient. Find the difference quotient for the function f of x equals, what was that one we did, the first one we, negative 3x plus what? Plus 1. That was that first function I gave you, right? I would like for us to find the difference quotient for that function. So, there are 3 pieces to a difference quotient. There is the top left, the top right, and then the denominator. Now the denominator is always h, so you don't have to do anything there, all right? There's no computation to do here. H is just h always. F of x, you don't have to do any computation either because you're actually given f of x, aren't you? The only real thing you have to do is this one right here, f of x plus h. That means you have to plug x plus h into that function. Didn't we do that already? Okay, so you're going to help me write this now. Here's our difference quotient. I'm going to write down right now f of x plus h because we did it earlier. We got negative 3x minus 3h plus 1. Isn't that what we had from earlier? Yes? Okay. So now here comes the difference quotient. The difference quotient is equal to this, right? F of x plus h. This right here. Plus 1. I'm going to put in parentheses. That's the top left, right? Then what? Minus 3x plus 1. Now how should I write that? Minus parentheses. Look. 3x, negative 3x, sorry, plus 1. Do not forget these parentheses right here. That's the biggest mistake I see with difference quotient. It's like students finally get to the point where they can do this, they're all happy about it, then they come over here and they forget this damn parentheses and they don't distribute the negative through and it throws everything off. F of x plus h minus f of x all over h. Now we have to finish this. It's not done. We have to clean it up. But does everyone understand the pieces of the difference quotient here? Okay. Does anybody have a guess as to what the answer to this is going to be? What is this if I graph that? That's the original function, right? If I graph it, isn't that a line with the slope of negative 3? Like this? And this answer should tell me if I went to x and I went to x plus h and I picked 2 points, it would give me the slope of that line, wouldn't it? But this is a line already. So what do you think the slope should be? What should this all turn out to be at the end? Negative 3. Because we started with a line. So finding the slope of a line, connecting 2 points that are already on a line, our answer should be negative 3. But it's only because we started with a line. The next example I do won't be a line. That won't work out so well. I was just curious if anyone could kind of see that first. All right, let's clean this up. Do I really need the parentheses around this? I don't. I only did it so you could see that that's the top left. Okay? So we have our difference quotient is equal to negative 3x minus 3h plus 1, and then what? Minus minus, right? I'm distributing. So isn't that plus 3h, or 3x? And then minus 3? I don't know why I put minus 3. It's supposed to be minus 1. Right? Plus 3x minus 1. All of this over, the entire thing over h. Now, do you see that some very interesting things happen up in the numerator? You get 3x's to cancel. You get the 1's to cancel. And all you're left with is negative 3h over h. And the h's cancel. And your answer is negative 3. Now, it's not always, look, this only worked this way because this was a line to start with. I most likely won't ask you to find the difference quotient of a line because we already know the slope of a line.
What do you mean? Like same at the exponent?
Yeah, I'm going to run out of time here, but let's at least set one up. What was the other problem I gave you? We're going to start a new problem here. I want us to find the difference quotient. It was negative x squared minus 4x plus 2. Remember that one? I gave you that function earlier? And I asked you to find the difference quotient. I asked you to find a couple of different things. But in one of the things I asked you to find this, didn't I? And we did, and it was real ugly, and we couldn't simplify it. What was it again? It was like minus x squared minus 2xh minus h squared minus 4x minus 4h plus 2. Was that it? There's no. There should have been a 4h here. Did I not put 4h down there?
Negative x squared minus 2x minus h squared minus 4x minus 4h plus 2.
Yeah. There should be a, when you distribute the parentheses right here. That right there and right there. Oh, you're missing the 4 there because the 4 goes to both. Yeah. Okay, this is what we had, right? So if I want the difference quotient now, what I'm going to do is take this, subtract this, and put it all over h. It's going to look horrible, but it actually is not going to be bad after we simplify. So the difference quotient here will be, I'm going to put in parentheses, I don't need it, but negative x squared minus 2xh minus h squared minus 4x minus 4h plus 2. That's just f of x plus h, right? Subtract from that and always put a parentheses. Now I put f of x here. And that's just minus x squared minus 4x plus 2. And that's all over h. Let's get rid of the parentheses. Negative x squared minus 2xh minus h squared minus 4x minus 4h plus 2 plus x squared plus 4x minus 2. So the negative going through here changes all the signs. So this becomes plus, plus, minus, all of this over h. And look, you're going to be working through these on your own at home. And, oh, you want your tests, right? You don't have to pick them up today. I'll leave them up. I'll call them out in a second. When we're going to practice a little bit more on Tuesday, but here's how you'll know if you're doing everything right. At this step right here, a bunch of stuff's going to cancel. X squared, 4x's cancel, the 2's cancel. Anything else cancel? No. What is still there though? What's left on top? Negative 2xh minus h squared minus 4h all over h. So I said, here's how you'll know if you're doing it right. Things will cancel, and everything that's left up top needs to have an h in it. You can't have anything there that doesn't have an h. Do you notice that they all have an h? Now what we're going to do is we're going to factor an h out of the top. Take an h out. Taking a single factor of h out. And now these cancel. And so your final result is negative 2x minus h minus 4. That's the answer. And in calculus, we would take it one additional step. And what we do is we try and slide that point over. And to slide that point over, we let h get really small. So imagine that this went away. Your answer would be negative 2x minus 4. But that's not this class. Our answer is that one right there. Okay, if you want your test, they're up here. Do you want me to just like spread them out up here, or you want me to call them out? Ashley, Jolene, Jared. You can go. If you don't want your test now, you can go. Ashley and Jolie. Jared. What's that? Yes, you can keep it. I'm going to do it based on this. Jared, Alexia, John Marcello, Jesus, Mark, Tressa? She's not here? Okay. Sierra, Gillian, is it Kane? All right. Miguel Ochoa, right? Derek Torres, or no, Derek? No, Derek. How do you say your last name?
C.
Okay, that's what I was going to say, but I didn't want to mess it up. Christian Prado, okay. Kobe, Mercedes, Zachary, Dylan, Brett, Ed.
No, it's not.
Who are you?
Ed.
Ed. Okay, there you go, Ed. Noah, Alex, Jordan, Aaron, Torres, and Renee. Okay. Hold on to it.
Okay.
Yep. Yeah, don't lose it though, because I'll ask for that.
Okay. Thank you.
Okay. I would say go home and look at those, and if you have any questions, I encourage you to come talk to me.
So we could redo number 8?
I'll let y'all know about that, because I need to hand it out to everyone, because not everyone has a copy of it. So I'll let y'all know next week how I'm going to handle that. I was trying to rush to get these graded and put them in. I didn't have time to put anything together.
Yeah, I took it.
So we hold on to it.
Yeah, hold on to that. Don't lose it.